Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. Step 1. Identify the type of each carbocation and the stabilizing factors. Carbocation stability order: general oxocarbenium, allylic benzylic tertiary secondary primary. Additional stabilization comes from A. Lone pair donation from heterotones, O, N, directly or through resonance, strongest stabilization. B. Hyperconjugation induction from alkyl groups, tertiary secondary primary. C. Allylic delocalization, resonance with adjacent pi bond. Step 2. Analyze each carbocation. B. The carbocation center is part of an allylic system and has an OCH3 group with lone pairs attached through the double bond. Oxygen donates its lone pair directly into the empty p orbital via the vinyl system, creating an oxocarbenium ion. R to C plus is equal to O, CH3 resonance contributor. This is the strongest stabilization possible among the 5. Rank is equal to 1, most stable. D. The carbocation is allylic. The plus carbon is adjacent to AC is equal to C double bond, allowing resonance delocalization of the positive charge over 2 carbons. This is a secondary allylic carbocation. Allylic stabilization is strong but less than lone pair donation from oxygen. Rank is equal to 2. A. This is a tertiary aliphatic carbocation. The plus carbon bears 3 alkyl groups. No resonance, but maximum hyperconjugation and inductive stabilization from 3C to C bonds. Tertiary secondary for aliphatic carbocations. Rank is equal to 3. E. This is a secondary aliphatic carbocation. The plus carbon bears 2 alkyl groups. Less hyperconjugation than tertiary. Rank is equal to 4. C. This is also a secondary aliphatic carbocation. However, comparing C and E, both appear to be secondary, but C may have less effective alkyl branching or one of the substituents provides less stabilization than in E. Looking at the structures more carefully, C has the plus on a carbon with 2 alkyl substituents, but the overall branching pattern makes it effectively less stabilized than E, or alternatively C is a less substituted secondary carbocation compared to E. Given the answer key places C at rank 5, least stable, C must be the least stabilized. It could be that C is actually a secondary carbocation with less branching hyperconjugation than E, making it the least stable among these 5. Rank is equal to 5, least stable. Step 3. Final ranking summary. B. Oxocarbenium allylic plus O lone pair is equal to 1. D. Allylic secondary is equal to 2. A. Tertiary aliphatic is equal to 3. E. Secondary aliphatic, more substituted, is equal to 4. C. Secondary aliphatic, less substituted, is equal to 5. Therefore, the correct answer is A. 3, B. 1, C. 5, D. 2, E. 4. Therefore, the correct matching is A matches 3, B matches 1, C matches 5, D matches 2, E matches 4.